Okay, we're going to take a look at scatter plots. Our essential question is, how can you construct and interpret scatter plots? So read along with me right here. A set of bivariate data includes two variables. That's where it says bi, that's two. Variate means variable, so two variable data. Bivariate data are used to explore the relationships between two variables. You can graph bivariate data on a scatter plot. A scatter plot is a graph with the points plotted to show the relationship between two sets of data. Okay, so let's take a look at our information here. So if we scroll down on the page, example number 1. Let me get my pen here, sorry. Example number 1. The final question on a math test reads, how many hours did you spend studying for this test? The teacher records the number of hours each student studied and the grade the student received on the test. So if we look at our table, this information is how many hours the student studied, and this was the test grade. Now this would be variable number 1, and this would be variable number 2. The reason is because we don't know how many hours were spent studying. It's not a fixed amount, and the test grade is not a fixed amount. So that's where when they talk about two variables being compared, this is what we're looking at. A says, make a prediction about the relationship between the number of hours spent studying and the test grades. So what they want you to do is they want you to take a look at the hours spent studying and the test grades that each student got. So it looks like we have a range from 0 to 4 hours. And these students did pretty well, about 75 to 100% on the test. So we've got a decent range of time and a decent range of scores. So take a minute, pause the video, and compare the scores of the students' grades depending on, comparing to how many hours they studied. Okay, so hopefully you noticed something like the more they studied, the better they did on the test. Now, there were a couple situations that are a little bit different. We have this guy studied for an hour and a half and got 95, and this guy studied for 4 hours and earned a 90. This student studied for 3 and earned 100%. So there are definitely some that stand out a little bit differently, but for the most part, the more the student spent studying, the more time, the better their score was. So other than a few students, the more you studied, the better your score was. So you have to figure out how to write that in your own words here. Okay, now let's take a look at B. Oops. B says, make a scatter plot, graph the hours spent studying as the independent variable and the test grade as the dependent variable. Try to get if we take a look, our independent variable is the time spent studying, and if we look at our graph, the hours spent studying is on our x coordinate, so the independent variable would be the x. Test grade is the dependent variable, so test grade is our dependent variable, or our y. And you'll notice that your independent variable is usually the x, the dependent is usually the y. So if we take a look and we start our graph here, let me find my paper. Student that was studying for 0 hours, 0 hours spent studying got a 75%. So now we're just going to start plotting. Half an hour is 80%. 1 hour is 80%, 1 hour 85%, 1.5 hours 85%, 1.5 hours 95%, 2 hours 90%. Oops. Get my eraser here. I'm going to make these two a little bit smaller. We're a little off here. So let's go back. 1.5 was 95. 2 was 95. 3 was 100. And 4 was a 90. So this guy that spent 4 hours and only got a 90 is definitely out of the norm here. He would be considered an outlier because compared to the trend that we have, he spent a lot of time. So he definitely either didn't sleep because he was studying for 4 hours and was not rested. There could be all kinds of things. So what your job is now is to take a look at your graph. So you're going to want to graph that yourself. And you're going to answer 1B and 1C on your own. Excuse me, 1A, 1B, and 1C all on your own. What trend do you see in the data? So they want to know what patterns do you see. Okay. 1B, do you think that studying for 10 hours would greatly increase a student's grade? So this just isn't your own personal opinion. Okay, we don't want your opinion on this. We want to know based on the trend. Okay, so this isn't just you thinking, yeah, for 10 hours, you should totally greatly increase your grade. This is not what's happening in your head. Look at that graph and make a determination. 1C, why might a student who studied fewer hours make a higher score? So now you have to decide, how did that happen for those couple kids that studied less and got a better grade? Okay, so go ahead and stop. This is the first part of that page. Once you finish, return to the video for the next page. Okay, our back side of this page says, read with me at the top. Association tells you how sets of data are related. A positive association means that both data sets increase together. A negative association means as one data set increases, the other decreases. No association means the changes in one set don't affect the other. So we see some examples here. This is positive, and what you'll notice is my data starts increasing from left to right. Negative, we're looking at a decrease. And a no association, you're basically looking at no pattern. Okay, so next passage says, when data shows a positive or negative association and falls along a line, there is a linear association. When data shows positive or negative but does not fall along a line, there's nonlinear. So what that would mean, for example, you won't see it on this page, but on this graph down here, if these points were all over the place, but still heading in a positive direction, do you see how my red dots are all going in an increasing pattern? They're really wide apart. I couldn't actually make a line. If I were to draw a line here through the middle, there's still so many points that were happening that are not included here. These points I could fit, and pardon me for not being straight, but I could create a line that was very close to the data. Okay, so be careful of that. Okay, let's look at example 2, determining association. Susan surveyed 20 people about the price of a cleaning product she developed. She asked each person whether they would buy the cleaner at different prices. A person may answer yes or no to more than one price. Susan's results are shown in the table. Okay, so what's happening in our table? What's happening in our table is that she's got, when the price was $2 of her product, she got 20 people to purchase it. When her price was $4, 19 people purchased it. When her price was $6, 17 people purchased it. So that's how this table is going. So we want to make a scatter plot so we can see if there's a pattern happening here. So at $2, 20 people purchased. At $4, 19 people purchased. At $6, 17 people purchased. At $8, 13 people purchased. At $10, 8 people purchased. And at $12, 2 people purchased. Okay, so there's her data. Make sure you have that because we're going to scroll down. Describe the type of association you see between price and number of people who would buy at that price. Explain. You're going to go ahead and do this part on your own. So take a look at the graph that we made and decide what type of association. Is it positive? Is it negative? And then we want you to describe it. Okay, so you would use some sort of sentence. You can't just say decreasing or increasing. You'd have to say the higher the price, the more people purchased, or the lower the price, the more people purchased. The higher the price, less people purchased. So tell me if it's positive or negative, and then describe what's happening. Okay, and our last one. Mine's a little fuzzy here, sorry about that. Read along the top with me. When a scatter plot shows a linear association, you can use a line model to model the relationship between the variables. A trend line is a straight line that comes closest to the points on a scatter plot. When drawing a trend line, ignore any outliers. So that's going to be important. An outlier is a data point that's very different from the rest of the data. So let's take a look. Joyce is training for a 10K race. For some of her training runs, she records the distance she ran and how many minutes she ran. Make a scatter plot of her jogging log. Okay, so if we look at our table here, we have her distance in miles and her time in minutes. My distance is my X value. My time is my Y. That's a horrible X, sorry. Okay, so she went 4 miles in 4 miles and 38 minutes. Just about there. Okay. 2 miles and 25 minutes. So this is each day that she runs, she kept a log. So the third time she ran for 1 mile in 7 minutes. Now, sometimes when you're training for a marathon, you might run multiple times in a day. This might be the distance she ran without a break. So it could be 4 miles, then she took a break, then 2 miles, and she took a break, and a mile. So that's why we have different entries. So the next one was 2 miles in 16 minutes. 3 miles, 26 minutes. 5 miles, 55 minutes. 2 miles, 20 minutes. 4 miles, 45 minutes. And 3 miles, 31 minutes. Okay. If you look at B, I'm not going to put it on the screen because I want to keep the marks there. It says to draw a trend line, use a straight edge to draw a line that has about the same number of points above and below. Ignore any outliers. So we're going to try to draw a line with about the same amount above and below. I've got just about the same amount above and below with my line here. So take a ruler, take the edge of your notebook, the folder, and try and get a line that's similar to mine. This is just a trend line. It tells us that we're increasing from left to right. It tells us that we can kind of make some predictions about the timing. Okay. So for C, use your trend line to predict how long it would take Joyce to run 4.5 miles.